Okay, welcome back. Now, we've finished 14, we're going on to 15 in section 2.9 of the of book 1, of book 4. Okay, so what are we being asked to do here? Hence solve this equation, factorize fully. This doesn't really mean anything as such except to factorize, in that the quadratic that comes out might be prime. They are suggesting it isn't, but it's lazy. I mean, if you're asked to factorize, it's always fully. Okay, let's do this. That's negative 13. And this is not 13 or negative 13, so that test is out of the way. We're going to have to pull out the calculator. Now you could start looking at what you could call that 8 instead of 1. You could call this minus 4 instead of 1. You could call this minus 28 instead of 1 and call this 24. And now what we're doing is testing for 2 or minus 2. And there you go. We have a hit here. Okay? So this is a 2z test, if you like. And we have a negative 20 and a plus 20. Okay? Which means 2 is fine, isn't it? The way it is. So f of 2 leads to 20 take 20 equals 0. Okay? So x minus 2 is a factor. And now we're going to proceed to polynomial division. And our choice, rather than long division, is synthetic division, because it's done in an instant. But if you want to do this by long division, x minus 2 into this, go ahead. I'm going to use 1 minus 1 minus 14 and 24, because I have no choice. They're the coefficients of the polynomial. And I'm going to use 2 as the root. So that is nice what we did there. And what I was thinking is, if 2 was going in there, this would not be worth the 1 that we used to talk about as if it was. It's worth 8. If 2 were going in here, it's minus 4. Now if 2 is going in here, it was getting multiplied by negative 14 and so on. So you probably followed that. 1 drops. Remainder 0 as expected. You see here two numbers that are 1 apart multiplying to 12. We know them very well. Okay, and we factorized fully as they asked us to do. I'm going to start off with the plus. The less extreme negative and the most extreme negative. And as we're going on in the next section to graphing, we should add now. Start getting into the habit. That gives us a y-axis here. Come up, come down, come up again. Now in terms of what does minus 14x tell us? It tells us you're coming down when you cut the y-axis. Good, I'm coming down. Okay, so that's the graph. Show that 1 is a root. Sure, that's something we would be looking for anyway. You don't have to ask us to do that. 3 minus 3 f of 1 equals 3 minus 3. Okay, so we're going to put 1 in. Putting in the root. Bring down the lead. Multiply. Add. Multiply. Add. Multiply. Remainder. x squared plus 6x plus 8 is the quotient. Two numbers add to 6, multiply to 8, 4 and 2. Check what they asked us. The other two roots. Okay, so the other two roots are negative 4 and negative 2. The minute you see naught and naught, you have two roots. And you have, that looks awfully like one we've done already. So the roots are 1, minus 1, and 4. And the factors are x minus 1, x plus 1, and x minus 4. So you say x is an element of this, if x is a root. You can if you want. That's minus 10. That's minus 10. So minus 1 is a root. So minus 1 into 1 to negative 11, negative 12. Can they think of any other? I think they're just repeating the same thing. Minus 1 is a root. What do they want? Solve. Minus 1, minus 4, 3. The set of roots equals 0 and 0. Is there something wrong? Same thing again. So this is x squared cubed plus naught x squared minus 7x minus 6. Okay, so that's minus 7. No, it's not. That's minus 6. And this is minus 6. You saw me very quiet. You noticed I wasn't talking at all there. And that's not because I was just pausing. It's because I was thinking, as in it wasn't just absolutely standard procedure for me. Because I'd made a mistake. I had said 1 take 7 is negative 7. Now we see negative 6 and negative 6. So minus 1 is a root. We'll proceed to synthetic division. With the minus 1. Are 1, 0, negative 7, negative 6. Drop down to 1, negative 1. Okay. So we've x squared minus x minus 6 remaining, and then as x3 and x2, with this dominated with the negative here. Okay, so minus 1 is root. We're solving, aren't we? Solve the thing. So we just need the roots. We already have minus 1. Minus 1, 3, minus 2. Question 18. Minus 1 and minus 3 are the roots. Okay, let's, they want us to. Okay, split it in two. So do it the way they want us to do it. F of minus 1, using the factor theorem, equals negative 2, and that's coming from here, negative 2 plus a, because the minus 1 squares away to 1, minus b, minus 3, that's 0, which allows me to say that a minus b, now with minus 5 here, which is 5 at the far side. Now f of minus 3, we're basically going to be seeing 27, 9, and 6 in the following way. 3 cubed is 27. Double that is 54, but there's a minus in there. 9, a, and 3 just on its own, negative 3b. Now it's equal to 0, so we can take the variable terms on the one side and constant terms on the other side. Minus 57 goes across to become 57. 3 goes into all of them, so I'll just tidy that up before we start to eliminate between the two equations. 3 minus b is 19. So we have, now I said I'll leave that to another method so we can assess whether the other method is easier. We've a minus b, 3a minus b is 19. Now to eliminate subtraction is the best way, and we'd rather subtract up because that gives us a positive number of a's, and 14, because that's the way we eliminate the b's, by subtraction. A is 7, and then I'll just sub that here. 7 take b is 5, 7 take 5 is b. B is 2. Now, it was a bit of work, wasn't it? We don't like to have to work too hard. Is there an easier way? Well, first of all, the minus 1 is telling us that the odds add to the even coefficients. Let's check that that's true in our solution. Is 2 plus 2 equal to 7 take 3? It is. So that's one formula. Yeah, but I don't think we're going to end up any better off. We're going to still end up with 2 linear equations to solve. So yeah, we're happy with that. So we actually applied the factor theorem, or we actually agreed that we like the factor theorem for that one. Okay, well if minus 1 is a root, as the factor theorem tells us, then odd coefficients add to even coefficients. K plus 1 for the odd coefficients, minus 7 for the even coefficients. So we set them equal to each other, and K is equal to minus 8. I dropped on some of the actual book solutions, but hopefully they got it right. We definitely got it right. But now find the value of K and the other two roots. Well, we have a root and we have determined the coefficients of the cubic. Let's write them in their determined form. We have a root of minus 1. And we carry out our polynomial division via synthetic division. Bring down the lead. Start multiplying and adding. and factorize this. You know, I'll just go straight into the factors here. I need to get to 12 with a gap of 4. And I need to see that this is minus, this is plus. So plus dominates. That's the dominant. That's plus and that's minus. Okay. Reminder, we know x plus 1. And find the other two factors. Well, we've done that. So x plus 6, x minus 2. Oh, I thought of a better way of doing them. Watch this. This is minus 2 as a root, and this is 3 as a root. So if I add the roots, hold on. Yeah. I gotta go monic. Remember, if it's monic, I can add the roots. So I still have, my idea still works, I just need to work a bit harder. So I'm still going to say minus 2 and 3 are the roots, or 2 roots. I'm going to divide across by 2. This is new maths now for me. This is brilliant. This is much easier than the previous way, I think. See, maths is a really creative thinking subject. It's a fantastic subject, isn't it? Minus 17 over 2x plus b over 2. So that's an equivalent polynomial. Essentially, if we think of a polynomial as wobbling up and down, and if we divide it by 2, we're just coming in shallower. We have words for that. Come on, I look up the word for that. Just a quick look at what we're going to be doing in the next session. Transformations. Do I have a transforms? I do here. Oh, I would like to have more in there. I must have put it somewhere else. Okay, I might have dropped it into factor theorem and there's no transforms here. We went to division. Just see, did I drop it there by sort of accident? No. Look, while I'm here, let me just show you a treat. For anyone who doesn't know about synthetic division again, where it comes from, I'm just going to explain it one more time. Okay, now you're just going to, you can just see where my pen is here. So we're dividing x plus 1, which is a factor, into this polynomial. And x goes into this once. That's the drop down, the leading coefficient. Okay. Even if it's 3, we make it 3 here. Later on, we dilate back if we have to. So that's your drop down, your lead coefficient. Now this is where this bit, x squared by x, is a total waste of time. Because you knew that was going to go. Because that's how you designed it. The next bit, x squared by 1, is multiplication, giving us x squared. Okay, now for us, that would be a negative version of this. So we're adding to get this. Okay. That's the adding straight down the column. Then comes your multiplying. And all of this can just be done with synthetic division in a few seconds. In this case, that has a remainder of 1. And here's the coolest thing of all. If you take that away from the 7 to make it 6, then x plus 1 goes in. And I'll be talking to you about that again. That's just absolutely brilliant. Anyway, let's get back to this bit of excitement here. So I've explained that, and we have dilated or we scaled down our polynomial, which doesn't change anything regarding the roots. Now, and I'm just going to write myself again, that minus 2, 3 are roots. So we're hunting for the third root, and getting A and B. So, well, what do we call it? Let's call it OR. So we'll add the 3 roots, and we get minus A over 2. So 3 take 2 is 1, OR plus 1. This isn't going to work at all, is it? And that's the true. This is proper maths. I'm actually exploring something, and I might have to abandon it and reconsider, and that's the way maths works. So you get minus A over 2. See, my problem is that there's 2 unknowns there, and now we're going to have another unknown. We're only going to have 2 equations. It's just not going to work. You multiply them together, make it 6 because I have a negation to carry out, and I'll have 6R equals B over 2. Okay, forget about it. Doesn't work. Thought it would. So you just go back in and fill in the 2 values, getting a linear equation, 2 separate linear equations in A and B. So I want to talk to you about that. Say you have an A axis and a B axis, and you have a linear equation in A and B. Okay, it's just probably at an angle, unless there's no B or no A in it. Okay, and then you have another linear equation in A and B. It might go like that. When you combine them by subtracting them, or subtracting 4 of one for the other, and if you combine them in any way, the one thing for sure is the new line that you combine up to has to go through that point. And this would not be elimination. Any of those what I'm drawing there would not be eliminating. But through elimination, you end up either getting a horizontal or a vertical, which allows you to solve for A or B, and then substitution gives you the other one. That's how the whole elimination things work, and I find not a lot of students really know why it works or what's going on graphically. So the graphical thing is the point of concurrency doesn't change, and you're looking for a vertical or a horizontal line. Okay, I better do this now after all that talk. So I have 3 and negative 2. Let's start off with a positive 3. 2 27s is 54. 9A minus 3 17s 51 minus 51, and B is B. Okay, what can we say about that? We can say through the factor theorem, f of 3 equals 0. Okay, the number bits here is worth 3. We'll take it across. Okay, let's put in minus 2. You get minus 16 for the first. You get 4A. You see, on the evens you don't really spend much time thinking about sign. Keep the sign of the coefficient. You get 34. And you get B. That's not. Tidy up your numbers. 34 takes 16 is 18. They're near equals there. Double 16 is nearly 34. 18 across minus 18. So I have 4A plus B equals minus 18, and 9A plus B equals minus 3. Subtract up. Subtract up. A is 3. Quick substitution here gives me 12. Ooh, very negative b. I'm a bit surprised. Negative 30. Check with the other one. 9 of them is 27, negative 30. So I'm a bit suspicious. Probably true, but I'm a bit suspicious, so I'm going to go back and check that everything is okay. So I'm going to reconstruct this with the determined values. Just another quick one. That's truly a variable, the x. But these are not variables really as such, they're parameters. And parameters come from the beginning of the alphabet. They're just things we don't know about this particular cubic, or we're trying to determine, but they are set down because of the information they gave us. And then true variables come from the end of the alphabet. It's that simple. So basically, a parameter is a number that is a place value for some number, but at the same time, it's seen as being fixed for the whole problem. Whereas a variable is truly a variable and can take on any value, albeit certain values for roots, etc. Okay, so I'm just saying here, what we're going to do is we're going to analyze the situation and certainly check that negative 2 and 3 are roots of our result. So we got, let's do that with synthetic division. We got 2, what was A? Sorry about it, you get C6 looking at this. 3, negative 17, and then B was this number that I was kind of surprised with, negative 30. It's probably all fine, but let's double check. We'll put 3 in because it's positive. Drop the 2, 6, 9, 27, 10, 30. Sure, everything is fine. Why would I ever doubt myself? Okay. And indeed, from there, you could have had the 2x squared plus 9x plus 10. Keep your 2's apart. (4x) and 5x is 9x. Negative 5 over 2, they're both positive. And negative 2, well, we knew negative 2. So definitely sure about that. I've definitely cracked it. Now, I've been waiting to tell you something. Long division is the only way to divide this in here. You can use the deterministic values. Long division or determine a central parameter. They're your two ways. Probably determine a central value is the easiest. And again, I'm not even sure that's going to work here. So, well, that's what makes it interesting. So let's start off with true long division. Sure, we have to give it a spin just for the once. So what are we saying with this? We've looked at 3 methods for polynomial division. And what I didn't really tell you is synthetic division only works. Well, I did, but synthetic division only works for linear. So this is a quadratic, so you just can't use synthetic division here. So how do I hardly even know how to do long division. I'll tell you what, we'll bring some of the ideas I've been talking about in here. We'll cut out as much of the redundancy as we can. So x squared into x cubed is ax. I won't bother with the first bit because I know it's going to go. So I'll take the second bit, which is minus 2ax squared. Okay, and I'll add them. And I'll get 8 plus 2ax squared here. And I'll divide x squared into that. And I'd say that. Oh dear. U plus bx. Oh, look at this, look at this, look at this. So, yeah, you see the way the minus 3 goes into the 6? See, we're only looking for a single number now. So minus 3 into 6 is minus 2. But I still have an a up there. x squared does that have factors? It does. This has been sort of making me put up my sleeves. So and any strategy that'll get you out, get it solved, will work. So what I'm going to do is I'm going to factorize this. Okay, so -1 and 3 are roots. But I have to warn you that if they did tell you that this was a factor of that, it doesn't have to have factorize. In fact, it doesn't have to factorize, and it's by all means they can make up one that doesn't. At least I think they can. Of course they can. So I could just come along here. We'll make up one in class where it doesn't factorize, and we'll really explore this and come up with a deep understanding, because you can see here that I'm barely getting through the question. So now I'm going to use the factor theorem to sub and get two independent equations in A and B. Subbing in -1 gives me -a 8 -b and 6. Now, but they'll come across to be negative because I set it to 0, and it makes sense to just change all the signs. Make sure you're happy with that. That was kind of a bit of a sleight of hand the way I did that, but make sure you're happy with it. Now I'm putting 3 in, so that'll be 27a. I'll just change the color here to keep it up nice and high. So I have 27a, and I have 32 determined, and I have I? No, I don't. Put 3 in, I get 27a. Put 3 in here, I get 8 9s is 72. Put 3 in here, I get 3b. And 6 is 6. They're all multiples of 3. So I just divide across by 3 before I do anything else. 60 and 12, 20 and 4. Divided by 3. Not divided by 3 was also not. So I have 9a plus b equals -26. And I have a plus b equals 14. I subtract down to keep the a's constant. 8a equals -40. A equals -5. B is 19. I could tell you why these come out like that. I can tell you how they make them up, which I will. We'll be talking about that soon. So -5 and 19. They don't start off with 19. They start with a much smaller number, and then it's the remainder theorem. It's incredible. You don't have to study it, but it's worth knowing. And it has come up in exams, which is a bit of a mystery because it isn't mentioned in the syllabus. Okay, so we have our two values, -5 and 19. Which is which? -5. Just check our synthetic division on the information that we have. Well, for information we ourselves have stolen out, we know 3 goes in. A bit messy, aren't I? -5 drops. 3 of them is -15. That's -7. 3 of them is -21. That's negative 40. Oh my god, not good. Negative 5 drops. 3 negative 5 is negative 15. That's negative 7. 3 times negative 21. So I made a mistake. Now, if you work through your exam really quickly, you bank away some time, so that when you do come in a problem, that you have to continually you have to show productive disposition, and you have to show stamina, and you have to show resolve, and you have to keep working on it, because one tiny slip might have made that not work out for me. Having said that, I probably have 9 out of 10 in what all the work I've done. I wouldn't be rubbing this out in an exam, obviously. It does just seem not to work. So we said there's no reason to have a quadratic when it factorizes. You might as well decompose it. That could have been my mistake. I can't even remember now. 3 or negative 1. Negative 1. Get the exact same thing, aren't I? I think the other one was wrong. So minus 5 going in there gives B is 19. That's 19. What you fancy? Minus 1? And put either in. We should end up getting minus 6 here. mistake. I know you've been looking for ages and ages, and you've just been saying, come on, come on, come on. 5. Not that I talked to you about before, just because you find a mistake doesn't mean you're out of the woods. Yeah, but I think we are. So one tiny slip, and this is showing you that you really, really can check your work. You don't have to walk away from it, just hoping you're right. So minus 1 by 13 is minus 13, and then this is 6, and then this is minus 6, and now I have the 0 that I wanted. So I am happy. Now I did have the right solution, I think, all along, didn't I? I think I did. I'll have to look back over the YouTube video. So of course it's quite ironic if your checking introduces a slip, then that's not going to cost you at all. You're going to get full marks, but it could cost you. It will cost you on time, like it did there for me. So there's learning in this. There's learning about the psychology of maths, and never give up. Well, you have to have a strategy about that too. But you saw that we're all fallible, and you saw that even I can run into a little bit of difficulty. That's one of the features of good problem solvers, is that you're tenacious. Okay, let's go down. Now we're going to have letters left in this, okay, just before you even think that you're not. You are. So let's separate. So this is what's called pure. This is a pure cubic. And it's going to be very easy to solve. So let's go. Isolate. So basically there's only an x cubed term. There's no x squareds, there's no x's. A pure quadratic doesn't have any x term. And it can be solved very simply by isolating the x squared term. It's the exact same thing here. So on we go. So ax cubed equals b plus c. Just generally we put the lower letter of the alphabet. That's the only reason I popped them into the beginning there. So I'm going to divide across by a. Now it's an equality, so it doesn't matter whether a is positive or negative. And now I'm going to take the cubed root. Now the cubed root is not multi-valued. There's no cubed root property where you put plus or minus in. So x equals the cubed root of b plus c over a, and you can't go much further than that. Okay, now if you expanded this, you would have x squared terms and x terms and everything. But the beauty of this is it's in what's the equivalent to vertex form. Okay, and we're going to look at graphs here, but basically this only has one root. It's a repeating 3 times. Okay, and that allows you to take the cubed root. It's, and when you say, so when I looked at the, when we talked about the vertex for a quadratic, the symmetry was axial symmetry. And we saw today how axial symmetry and even function like a quadratic go hand in hand. Well, central symmetry is what rules the roost in cubics, as long as they're written with a repeating factor. Now, it isn't actually a factor as such, in that minus b is not the solution to this, making it 0. But as long as you can isolate a linear term and cube it, you're good to go to kind of unravel that cubing. I hope you understand that. We'll have plenty of visuals, and in GeoGebra there'll be plenty of dynamic manipulatives that you'll be looking at, or just go into that polynomial Padlet I gave you and you'll find them. So you'll isolate the power term. And now you'll take the cubed root of both sides, which is single valued. And now you'll think, well, I'm getting on great here. Whoops, see. But I haven't isolated x yet. So you'll just finish it out. Like that. But it didn't. I never went on to get that, but I should have done and could have done. Okay, I think that's a good day's work, especially when you consider the 2 videos. Creeping on towards the end of the week, I'll talk to you about assessment. I think what we need to do is just park it here. We'll see. We'll talk to you tomorrow, but I think we'll park it here and look at. It's a pity though, those polynomials are really interesting, those higher order polynomials. Just not going to give you enough time to study. So I think we'll park it here and do the higher order polynomials after break.